In this video, you're going to learn to solve word problems that have two unknowns using a system of linear equations. Let's take a look at this example. Edmund invested $5,000, part of it at 4% interest and part of it at 2% interest. If the total income for 1 year was $144, how much was invested at each rate? Well, what we have going on here is we have part of an investment at 4% interest and part of an investment at 2% interest. Those are my two unknowns. So we have an amount invested at 4%. We don't know what that is, so I'll call that X. And we have amount invested at 2%. It's a different amount than we have invested at 4%, so I'm going to call that Y. Since I have two unknowns here, I want to write two equations. And the first equation is easy to get. Edmund invested $5,000 in total. So if I take the amount that he's invested at 4% plus the amount he's invested at 2%, we get a total of $5,000 invested. My next equation is going to come from the amount of interest he's earned on these accounts, which is $144. So he's earned $144 on these accounts. How is he going to earn that money with an investment? Well, he's going to earn interest on those investments. And so 4%, if I write that as a decimal, is 0.04. The amount he's invested at 4% was X. That's the amount he's going to earn from his account of 4%. Now I want to add to that the amount that he's going to earn from the account at 2%, which is then 0.02y. Now I have my two equations I want to solve. Well, the first thing I'm going to do is try to get one of these variables to drop out. And I'm going to do that by making these y variables drop out. Now it would be ideal if in this lower equation down here, instead of 0.02, I could have a -1. So I'm going to multiply by something to give myself a -1 down there. So really this is what's going on. I'm taking that 0.02, I want to multiply it by something to give me a -1. So I have a little equation here. I'm going to solve that equation, divide both sides by 0.02. And when I do that division, I'll get that z is equal to -50. That tells me I need to take this account up here and multiply it by a -50. Erase that scratch work now. Okay. I'm going to go through now and multiply by this -50. So -50 times 0.04, when I do that multiplication, I get -2x. And when I take -50 times 0.02, we already talked about that, that's going to give me a -1y. And when I take -50 times 144, that's going to give me -7,200. Okay? Now I'm going to add these together to eliminate the y variables, and we're going to have to kind of jump across this middle equation, so ignore that. So I'm taking this top value, x, and I'm going to add to that a -2x. When I add those together, that's going to give me -x. Now when I take the y plus the -1y, that's going to give me 0, like we talked about. The y's drop out. And then when I take a 5,000 plus this -7,200, it gives me -2,200. So since a -x equals -2,200, I divide both sides by -1, and I'll see that x is equal to 2,200. All right, I'm halfway there. I've solved for x. If I plug this value back up into my original equation there, x plus y equals 5,000, I can figure out how much y is. So let's take a look. I'll have 2,200 plus y equals 5,000. So I would subtract 2,200 from each side. And I'll see that y then, when I do that subtraction, I get 2,800. And so there are my two answers. Invested at 4% is 2,200. Invested at 2% is 2,800. Now it's time to practice solving a word problem with two unknowns using a system of linear equations. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Okay, a 100-pound mixture of two different grades of coffee costs $277.50. If grade A costs $3 per pound and grade B costs $2.50 per pound, how many pounds of each grade were used? Well, we have our two unknowns. We have this grade A coffee, so we have the pounds of grade A. And now we're used to usually using X and Y, so I'll go ahead and call that X. We could have called it A. That would have made a lot of sense here too. And then we also have pounds of grade B. So we'll call that Y. Okay, now we're looking for our two equations. The first one is easy to find. There's 100 pounds of this mixture. So if I add the pounds of grade A, which we're calling X, plus the pounds of grade B, which we're calling Y, altogether that's 100 pounds of coffee. Okay, our next equation comes from this total price of $277.50. How do we come up with that total? Well, it's $3 per pound for the grade A coffee. So I would say $3 per pound of the grade A coffee plus $2.50 per pound of the grade B. So I would say, and I'll call that 2.5 of the grade B. There are my two equations. I want to try to eliminate one of these variables, and notice those X variables would be pretty easy to eliminate. If I take this top equation and I multiply it by -3, then I would get a -3x, and when I added that -3x to the positive 3x, the X variables would drop out. So I'm going to go ahead and multiply that, but I'll write it down below. So I'm multiplying this -3 by all the terms up here, and so let's see, -3 times X would give me a -3x, a -3 times Y would give me a -3y, and then finally a -3 times 100 would give me -300. So I'm going to go ahead and add these equations together to drop that X variable out. And you can see 3x minus 3 plus a -3x, it gives me 0. Positive 2.5y plus -3y would give me a -0.5y. And then 277.50 plus -300, when I add that together, I get -22.5. Solving for y here, so I'm going to divide both sides by -0.5. When I do that division, I come up with 45. So we're halfway there. I've solved for y, and I know that the grade B coffee, we got 45 pounds of that. So what I want to do now is I want to plug that y back up into my original equation up here, where I had x plus y equals 100. So this is what that would look like. We see x plus 45 equals 100. I would subtract 45 from both sides, and then we'd get x equals 55. Now, since we were talking about pounds of coffee here, we would say 55 pounds, 45 pounds, and now we know how much grade A coffee and grade B coffee we need to get these two stipulations. It adds to 100 altogether, 100 pounds, and it gives us a total price of $277.50.